You are in office today.
This is an institute.
Okay.
I'm doing work from home. Didn't I tell you?
I didn't remember.
Okay, no problem. Okay, see, in this, we have done I2C, right? Remaining all codes are almost the same. The only difference is constraints. Constraints is different how you are passing test cases to check its corners, and it's the way it is built. Here, most of the time, design is also given, and verification both are given. But in real time, you need not to do any design. Design comes from the another team. They are called designers. They will design, two or three people will design a spec, and they will give it to you. Okay, it will come to the your table. Now it's your duty to verify whether that device is working properly or not. So how you will come to know that whether that device, what is it, how it is functioning, functional thing. If it is simple a full adder or a adder FIFO queue, these things you can tell directly. These are like simple things. What are the things? But there will be like SOCs. SOC in the sense of lakhs of lakhs of lines of code. How you will come to know? The simple way, whatever they'll write with the spec. Okay, for each and everything they has to be noted down in a spec. They are called a specification document, specs. So once if you read spec, then you can understand that the behavior, the RTL design, where are the conditions to apply constraints, where are the conditions to apply, what sort of test cases and all you will get. So you will write accordingly. So we will discuss this. Definitely we will discuss. But prior to this, we will go to UVM. Okay. Today it's not too early. Okay. Already we came up with so much knowledge. So now we will jump start to UVM, and we will see how UVM much easier than SV. In SV, you need to write down each and everything. But in UVM, it is not like that. UVM, simply uh, you can inherit, you can use some commands. No, those are not commands, those are like scripts. Okay, to get the solution. So easy, so constructive, and that is the final. Okay. After SV, there is like OVM that is failed. UVM, it has stabilized. It is now currently using, and in future also more than this won't come, I guess. That much beautiful it is. Okay. Now we will go about to UVM not required. UVM tutorial. Okay. It's like how it is evolved. All those things will become. Introduction to UVM, test bench hierarchy and block diagram, utility and field macros, methods with example, create, copy, compare, unpack, print, clone, pack, sequence methods, sequence macros, sequence example codes, UM sequence control, UM sequence with example, UM configure DB, set method, get method, UM phases in detail, UVM driver example, UVM monitor example, agent example, scoreboard example, environment. With this, entire test bench will be covered. This is our test bench. So first we will go to introduction to UVM. Universal verification method consists of class libraries, class library needed for development of well constructed reusable system Verilog based verification environment. This is reusable. Okay, this is in system Verilog reusability is not there. In simple words, UVM consists of set of base classes with methods defined in it. See, whatever the things you want for test bench, the everything was already uh, already defined in UVM. All you need to do is you need to implement those things. Okay, you need to extend those
Okay.
parameters, methods, and classes. All these things were already prototyped in the UVM. The system Verilog verification environment can be developed by extending these base classes. System Verilog only, okay, but system Verilog we will write explicitly class, right? Wherever we want to class for each and every each and every test bench module we will write class. But here it is not the case. Here we will create a child calls of that, and we will get those properties and we will use it. We will execute and run it. In this, two things will be there. Okay, one is UVM object and another one is UVM component. UVM transaction is in normal like transaction like SV only. What is UVM? Okay, based on this UVM transaction and UVM component, these things, based on these things, you need to grab those things. You need to make a factory, utilities factory. In that, you need to register. After registering it, you can access. You can access. Otherwise, you cannot access. So, who are objects? Who are components? We will see. Object. Core class-based operation methods create, copy, clone, compare, print, record, etc. Instance identification fields name or type name, unique ID, etc. The random seeding were defined in it. All UVM transaction and all UVM transaction and UVM components were derived from the UVM object. UVM object is the top node. This is like a nodal system. Okay, this is the top node. From this UVM components and UVM object were derived. Okay, I'll write. This is UVM. What is that? UVM object. Here, UVM object and UVM component were derived from this. From this, some classes were derived. Okay. Here, some classes names will be looks bit different, but don't compare. Don't confuse. UM transaction used in stimulus generation and analysis, same as SV only. Okay, UM transaction, UM component. Uh, Component are quasi-static Objects exist throughout the simulation. Every UVM component is uniquely addressable via hierarchical path name, environment dot agent dot driver. See, there is a path. This path also you need to remember, environment dot agent dot driver. UVM component also defines phased test flow that components follow during the course of the simulation. Each phase, build phase, connect phase, run phase. There are actually 20 phases are there. Okay, all 20 phases, if you learn, you will get confused. But mainly we'll use, okay, those phases, very rarely we will use. At that time only you learn better, it is better. But you will get confused if you use 20 phases. Better you use build phase, connect phase, run phase. Okay, build phase we uh, will build the hierarchy. Connect phase we will connect the ports. Here two types of ports will be there. One is UVM ports, I mean TLM ports, and another one is analysis ports. Okay, and defined by a callback that is executed in precise order. UVM component also defines configuration, reporting, transaction, recalling factory interfaces. This looks UVM class hierarchy. This is UVM class hierarchy, but I don't want to show you this. You'll get confused. I'll get much more simpler than this. UVM test bench. UVM test bench hierarchy. This is how test environment, agent 1, agent 2, agent 10, scoreboard. These are all the agents. In agent, in each agent, same thing will be there. Driver sequencer monitor. Okay. Driver sequencer monitor. Driver sequencer monitor.
कर दिया अप्रूव उन्होंने। हाँ हाँ अप्रूव कर दिया। तुम वहां पे जाके मेल दिखा सकते हो उनको, मेल की स्क्रीनशॉट में भेज दूंगी। हाँ तो सॉफ्टवेयर ले लेना उनसे।
Configure in the test bench. Okay. Initiate test bench component construction process. Building the next level down in the hierarchy of example environment. Initiate the testimonial process by building next level down in the hierarchy. Initiate the simulation by stating the sequence. UVM environment. Environment. The environment is container component of group of higher level of components like agents and scoreboards. Agents and scoreboards will be there on this. In agent, what are all they there? Here, see. Driver, sequencer, monitor. Sequencer also we will get sequences from sequences. Okay, we will get sequences. For sequences also we need to get sequence item. Okay, from that we will get UVM agent group the UVM components specific to an interface protocol. Example groups the component associated with BF, bus functional model. BFM means bus functional model. Components are agents. Bus sequence item. The sequence item defines the pin level activity generated by agent to the DUT through the driver, or activity has to be observed by agent. Placeholder for the activity monitored by the monitor on the DUT signals. UVM sequence. Define UVM sequence in which the data items need to be generated, sent, received to from the driver. UVM sequencer. This is UVM sequence. In sequence which data items need to be generated. Here we are generating the data items. UVM sequencer responsible for routing the packet or sequence item generated in sequence to the driver. It is the responsible for transferring sequencer. UVM monitor observes the pin level activity and interface signals and converts it into packet level, which is sent to components such as core boards. This is it. This also, the same thing you will do in SV also. Okay. UVM scoreboard. UVM receives the data items from monitors and compares with the expected value. Expected values can be either golden reference values are generated from the reference model. Okay. For a detailed expression of each component methods, refer to UVM tutorial. This is how it look like. Okay. Previous one I thought I don't want to show you. See here, sequencer. Okay, it is from the sequence, it is generated the sequence randomized value through sequencer. This is called port. Okay, this 0 to square, 0 to square. This is called TLM port. Via TLM port only this will transact. Earlier there is a mailbox, right? Those will go from here to here magically. Put get methods. But here TLM ports, through TLM ports it will transfer the data. After that, driver interface DUT pin level information will be there on the DUT. Pin level information are there on the DUT means it is there on the interface too. Okay, it will connect to monitor, monitor to scoreboard. This is analysis port. See, this is like a I mean rhombus shape. So this is analysis port. See, there will be a scoreboard, there will be n number of agents, n number of agents, n number of agents. This is so much generalized. This can be for as big as any big circuit. See, for example, uh, Delhi Metro, right? DMRC.
Yes, yes.
There also you can use UVM verification. There,
Okay.
there will be FSMs. See, there are so many FSMs. Okay,
Field
if you
sales
cross the
manager,
line, huh?
field service manager.
No, not field service manager. Those electronic circuits will be there, right? Completely electronic circuits, right? Metro means.
Okay, okay,
Okay, those
okay,
doors will open automatically. After that distance comes, they will sense the sensors if they reach or not. It's the same point they will stand. See, they will put some arrow
okay,
mark symbol. There only it will stand so that there only people can come, enter or leave. So again, you'll have either card or a token coin. Okay, if you place the scan, it will scan. Again, it will remember that value. It will again where to leave. That information will be there on that. If you leave other than that station, before that station, it's not a problem. After that station, it will be a problem. Before the station also, it won't allow. You have to go to that last station, whichever the token is taken. So all those information is there on the system, how we will process. See, there will be a design in that they will design the circuitry, and that circuitry you need to verify properly whether it should work or not. For future endeavors also you need to work. These are not like simple things like traffic lights, ATMs, and all. This has gone very huge now. Electronics, okay, or electronic automotive systems, okay, the driverless
okay.
cars. These things are all taken care by these designs. Those designs only you will get in future. So be ready for that. You should have a knowledge and sensors and all. Do you know how to prepare Word properly?
Word document.
Word document.
Yes.
I have one doubt here. See, I need to submit this document.
Okay.
Here I need to write something. How to write?
You can call a text box,
Okay, okay. Now it is.
calling out a text box, and you can write in the text box.
No, no, no. The text box don't work here.
No, it will work. It will work anyway.
See, it is not coming. Where should I go? Tell me.
Uh, just give me 2 seconds. insert text box के लिए कहाँ है text
Okay.
box? इंसर्ट में होगा, ये रहा टेक्स्ट बॉक्स ए, पेज नंबर के बगल में, इन द नेबर ऑफ पेज नंबर, हेडर फुटर पेज नंबर, देन देयर इज टेक्स्ट।
Text box, right?
ये
So which one I should choose?
सिंपल टेक्स्ट बॉक्स।
Okay. Text box came like this.
देन मेक इट स्मॉल, ड्रैग फ्रॉम ऑल द साइड्स एंड मेक इट स्मॉल। हाँ, नाउ यू कैन डिलीट द टेक्स्ट रिटर्न एंड राइट योर ओन टेक्स्ट, then you can drag it anywhere you want to place.
I need to submit this today.
Okay, for to the institution
No, no.
in the office.
Yeah, yeah.
You can just place the cursor and delete this text and write your own text. And then you can change the font or size of the font or whatever you want by selecting the text.
Okay, thank you. Thank you for that.
Oh. Your
And
arrows in the diagram are not placed properly.
yeah, yeah. So with this, okay, we will go to next UM sequence item. We talked about UM sequence item. UM sequence item is written by extending the UM sequence item. Okay, UM sequence
Okay.
item inherits from the UM object via UM transaction class. Okay, therefore UM sequence item is an objective type. Like this it will be. Don't read all these things. Read this utility macro. The utility macro powered the implementation of the create method needed for cloning. If you want to clone means this is factory settings. You need to register in this. Okay, and the get type of name method, name debugging object with no field macros. Here you need to type it. Okay, after that object with the field macros, tick object with utils macros type tick field field flag, tick object utils send field macros. Field macros are invoked inside of the star utils, begin with the star utils end for the implementation of the methods copy, compare, pack, unpack, record, print, and etc. See, these are the things it will be there. UVM, each UVM field macro is named corresponding to a particular data type, integers, strings, objects, queues, each at least two arguments, fields and flag. See this Neha.
Yes.
You do one thing. I am reading the theory unnecessarily. What you do is you go through the theory part.
Okay, you can send me
Till
the link.
program. Okay, I'm sending the link. You go
You
through.
can.
If you don't understand, then ask me. I'll tell you. After that, programs
Okay.
onwards we will do. Okay. This huge
Okay.
theory is there.
Okay.
Okay, we'll see after this. Tomorrow mostly we'll connect. Okay.
Okay.
Okay. Bye.